so that others that aren't here can watch it. And if you have any questions, feel free to just either ask them, or you can put them in the chat if you want. I will keep an eye on it. So if you have any questions as we go along. So I think the easiest thing to do is I'm going to actually switch my camera here. I have a document camera. All right, can you see that okay? So quick review before I do a couple of problems. So what I'm going to do today is I had a couple students asking about this latest homework on finding the latitude using the sun or finding the altitude of the sun. So I thought I'd just do some more example problems because there weren't many example problems in the videos. I think there were a couple, but I can do a few more. But feel free to ask if you have any questions. But before we get started on that, I'm just going to do a quick review of the things you need to know to be able to do these problems. The biggest thing you need to know, and that's why we spent last week on, is understanding how the celestial sphere works. So here's our celestial sphere, and we have reference points on it. We have the north celestial pole, south celestial pole, and then around the center, halfway in between, we have the celestial equator. All right, and last week's assignment, you had to figure out at a specific position on the Earth using these kind of diagrams. And we call these Herb diagrams because I call my astronomer Herb. Is figuring out what the altitude of the celestial equator is, because the Earth is in here, and it depends on where you live on the Earth, especially your latitude, where the celestial equator is in your sky. And so once you know where the celestial equator is, then we got to figure out where the sun is. So what we're doing is we're just extending last week's celestial equator altitude, and we're just adding the sun to that. Okay? So now the key to the sun, as if I draw my sun here, is the sun doesn't follow the celestial equator. The sun follows the path called the ecliptic, and the ecliptic is tilted at an angle here of 23.5 degrees. So what that means is the sun, at different times during the year, goes above and below the celestial equator. And so in this class, all we worry about are 4 specific points. And these are the only ones that are going to be on any of the problems, either one of these 4 points. Now this point up here, the ecliptic is the line, but this point right here is what we call the summer solstice, because that's when the sun is furthest north in the sky and it has a declination of 23.5 degrees, exactly equal to the tilt. And on exactly opposite that is the winter solstice. Which is at a declination of negative 23.5 degrees. Remember that anything below the celestial equator has a negative declination, anything above it has a positive declination. The other 2 points, these are called the equinoxes. This one is the autumnal equinox. I'm sorry, I got that backwards. This is the vernal equinox. This is the autumnal equinox back here. And since the sun takes a whole year to go around our sky, you know, we know that's not the sun going around the sky, the Earth is going around it, but it works to think of it this way. On this day, the summer solstice is always going to occur around June 22nd every year. Okay? But it's not exactly June 22nd. It's going to be close to that. It can be the 21st or the 23rd, depending on whether we had a leap year that year. It switches because our calendar moves around. The autumnal equinox is September 22nd. That's the one we're heading towards right now. So we're about September 1st. So the sun is right here and it's getting lower in our sky every day. The declination is decreasing. Winter solstice is on December 22nd, give or take. And the vernal equinox is going to be March 22nd. Again, somewhere around there. Notice on the equinoxes, the declination of the sun is exactly 0 degrees. Okay? Because the sun on those two dates is exactly on the celestial equator, and that's where we measure declination from. So if it's on it, it's at 0 degrees. All right. Does that kind of make sense? So for some, let's do for a latitude of 30 degrees. I'm just going to do an example over here. So we're going to, on the homework, you're going to do a picture like this kind of diagram. The first thing you do is if you know the latitude, we're always going to, I always assume you're in the northern hemisphere. So that means you're always going to go up. Whatever your latitude is, in this case is 30 degrees, that's where you're going to put the north celestial pole. So this always is your latitude. I almost always do. I think I have one problem on the other test, on the other homework that had the southern one, just to kind of see if you could do it. It's okay to do it in the southern hemisphere, but everything just flipped over. It's like a mirror image of it. Yeah. All right, and then from there, you always go exactly 90 degrees. So once you know where the north celestial pole is, you go exactly 90 degrees. That gives you the celestial equator. And this angle over here is the altitude of the celestial equator. The very first homework, all you did was calculate that altitude. And to do that, you just take 180, because this is half of a circle, minus 90 plus 30. So if you add those two together and I subtract from 180, that's going to leave me that amount. In this case, it would be 60 degrees, and that's the altitude of the celestial equator. Okay. Now you're saying, oh, that was all the first homework. How do we add the sun in? Well, the sun, you always have to know exactly what day of the year it is. So it has to be in this class. I'm only going to ask you one of those 4 days. Now there are charts and we know exactly the declination of the sun. You could do it every day of the year. But for this class, all I would expect you to do is to know these 4 positions. So it'll be one of those 4 positions. So let's say at this latitude, we want to find the altitude.
Because it was kind of toward the end, and she was already sitting
Of the sun.
Autumn. I thought Autumn was here yesterday too.
On the summer solstice.
Autumn wasn't here yesterday.
She wasn't?
She was absent.
Oh, okay. And
Okay.
sunshine too.
Same diagram. I already know what the celestial equator is. It's at an altitude of 60 degrees, so I can put a 60 right there.
Sunshine was here yesterday, but
all right, and so what I'm going to do is I'm going to put the sun on here. And so I'm going to say, oh, on the summer solstice, I look back to this diagram and say, oh, summer solstice, the sun is up here. It has a declination of 23.5. And so that means it's 23.5 degrees above the celestial equator. So I just go to my diagram. Oh, here's the celestial equator. I'm going to go 23.5 above it because it's positive. So I'm going to go up here, put the sun right here, because I know that this angle is 23.5 degrees for the summer solstice. Then I just do 60 plus 23.5 gives me that the sun has an altitude of 83.5 degrees. Does that make sense?
Yes, it does.
If I was going to do the winter solstice, I would have put the sun down here, 23.5 below it, and I would have taken 60 minus 23.5. So on the winter solstice, I would have taken 60 minus 23.5 degrees, which is 36.5 degrees. Because the sun is here. So this is the sun on the summer solstice up here. So it's still 23.5. It's just the other side. This is the sun on the winter solstice. Okay. That difference has to always be exactly 47 degrees. No matter where you're on the earth, the difference between the summer sun and the winter sun is 47 degrees. Now, if you live on the North Pole, half the time it's below the horizon, but the difference is still 47 degrees. All right, let's do an example. So I wrote up an example here. Okay. Now, you should try this on your own. You got your piece of paper? Follow along. Instead of just watching me do it, see if you can do it yourself. So you're going to start out like this. I'm going to get you started. You're going to draw your herb diagram, your half circle. Put Herb or whoever you want to call him. I call him Herb, but you can call him whatever you want in the center. That's how we start every one. Okay. Now we know what our latitude is. Our latitude is 52 degrees north. Okay. Which is the latitude of like London. So we're going to go up here and I'm going to make this angle about 52 degrees. So more than half. That might be a little bit big, but you get the idea. This, remember, has to be my north celestial pole. So far, so good. And then I'm going to go from there. I'm going to go 90 degrees from that and put the celestial equator. Okay, same steps every time. If you know the latitude, this is what you do. And then we determine the altitude of the celestial equator. And we do this by going 180 minus 90 plus 52. And you can plug that in your calculator. I do it in my head, but I've been doing this for 30 years, so it's easy. All right, and so I get 38 degrees, means this angle, or the altitude of the celestial equator, is 38 degrees. But the question didn't ask for the altitude of the celestial equator, it asked for what the altitude of the sun is on these specific days. So I'm going to do the summer solstice first. Summer solstice, the sun is 23.5 degrees north, or positive. Here's the sun on the summer solstice. And so for the summer solstice, I just take 38 plus 23.5 degrees, which gives me 61.5 degrees. Then on the winter solstice, I'm going to put the sun down here. And remember, this angle is still 23.5. It's just 23.5 south, or negative. So this becomes 38 minus 23.5 degrees. And that should be 14.5 degrees. Correct me if I make a mistake. And then on the equinoxes, it's actually very easy because the declination of the sun is 0. So the sun is right here on the equinoxes. So essentially it's 38 plus 0, or just 38 degrees. Questions about that? Any questions? So far, so good? Don't hear any questions. All right. Now let's try one of our latitude ones. And you're like, oh, he never asked that before. Yeah, I didn't, but you do it exactly the same way. We're just going to work the problem backwards. So here's the problem. So the problem is the sun is at an altitude of 27.5 degrees. What is your latitude? We're going to draw the same exact drawing. North, south. Okay. But we're not given our latitude, so we can't put the north celestial pole in. We don't know where it's at. The only thing we're given, if you read the problem, is we're given that the sun has an altitude of 27.5 degrees. But we know remember we're always biased by the that we're in the northern hemisphere, is that the sun's always going to be above the south horizon. And so I can put the sun. So the sun is here, and remember altitude is just always how far you are above this line. And so that angle is 27.5 degrees. And I'm also told what day of the year it is. It is the winter solstice, which remember is December 22nd. And on December 22nd, if I go back here, December 22nd down here, the sun has a declination of minus 23.5 degrees, which means the sun is 23.5 degrees south of the celestial equator or below the celestial equator. So that tells me where the celestial equator is. If the sun has to be below the celestial equator, then the celestial equator has to be here 23.5 degrees above it. Okay, and then once I have the celestial equator, I go exactly 90 degrees from that, just like I did before, to the north celestial pole. And now the difference is I want to get this angle here. This is our latitude. It's also the altitude of the north celestial pole. So I know it's a whole thing's 180 degrees, so I just take 180. Now I have to add all this together, 90 minus, plus 23.5 plus 27.5. So I just add all those angles together, which gives me that whole part. Subtract from 180, that's going to leave my latitude. Which, if I did it right, is 39 degrees. I'm going to check on the calculator just to make sure. And so my answer is 39 degrees north. Remember, it's a latitude, so you need to put north or south after it. Questions about that? I know this always makes sense when I do it, but then you get on your own and it doesn't make sense anymore. So, but if you do it more, the more you do it, the more you practice, the more it'll just totally make sense. The key points here is I started out knowing where the sun was, so I put the sun on first. And then I figured out where the celestial equator is from the date. Sorry, was that a question? And then once you have the celestial equator, you go 90 degrees to the north celestial pole, and then you use the fact that it's all 180 degrees to figure out your latitude. Let's do another one. How about this one? All right, so right now, do a piece of paper and see if you can do it. And I will give you a few minutes, and then I will do it and see if you get the right answer. All right, hopefully, started out with a picture like this, right? north, south, put Herb in the center. Now the sun, or what we're told is the sun is at an altitude of 88.5 degrees. So the key points are here, 88.5, and summer solstice are the things we need to know. So the sun is 88.5 degrees. Remember, if I don't tell you, I always assume it's above the south point. So you're going to start from the south point. I'm going to go up 88.5 degrees. So this is very high in the sky. Here's the sun. This angle is 88.5 degrees. Okay. And I know it's the summer solstice. So on the summer solstice, the sun is where? The sun is at a declination of 23.5 degrees, which means it's 23.5 degrees above the celestial equator. So my celestial equator here has to be below it by 23.5 degrees. So the sun can be above it, 23.5 degrees on the summer solstice. Now, this is where students make mistakes. Don't make this mistake. Here's the celestial equator. I have to put the north celestial pole. The north celestial pole is always 90 degrees from the celestial equator. It's not 90 degrees from the sun. It's always 90 degrees from the celestial equator. So I'm going to go 90 degrees from there, put the north celestial pole. So this is 90 degrees from the celestial equator. Okay. Now, the key is what I really need to know is I need to know this angle here, because this one plus the 90 then just leaves that amount left. So I'm going to figure out what the altitude of the celestial equator is. And that's really easy because I know the sun is at 88.5. And the difference here is 23.5, so I just subtract that. So I get 65 degrees. Now we can just think about this and think, oh, does that make sense? Yeah, because if I take my 65 degrees and I add it to 23.5, I get 88.5 degrees, which matches what the altitude of the sun was. So now I just need to figure out this angle right here. I just say, oh, 180 minus 90 plus 65 leaves 25 degrees. Your answer is 25 degrees north. Now, if you're starting to really understand this, you could have looked at this a different way. On the summer solstice, if you remember from the videos, the sun is directly overhead the Tropic of Cancer, which is a latitude of 23.5 degrees. Okay, but this isn't directly overhead. It's 1.5 degrees off from being overhead. So you're 1.5 degrees further north than the Tropic of Cancer. Or you do 23.5 plus 1.5 and you get 25 degrees north. All right. Questions? Anything else you have questions about so far in the class? Do you want me to do another example, or is this starting to make sense?
Can you do one more example?
Okay. Do you want it the latitude kind? Finding your latitude?
Yes.
Okay. All right. Let me just make up one here. What is your latitude if sun is at an altitude of 43 degrees on the winter solstice. All right, we're going to start every problem like this. And we know the sun is at an altitude of 43 degrees. So this is 43 degrees. Here's the sun. Okay, that should be very easy just from reading the problem. I haven't really done anything yet. The only tricky part to these problems at all is figuring out where the celestial equator is. Because once you got that, you can figure out the latitude. But we have to figure out where the celestial equator is, and you have to do that by looking at the date. Remember, winter solstice, is the celestial equator going to be down here, or is it going to be up here?
It's gonna
At
be
the
down there.
top.
Up, yeah, because on the winter solstice, the sun has to be below the celestial equator, right?
Mm-hmm.
So the celestial equator has to be above it. And remember, there's only the one angle. It's always either 23.5 or 0. There's no anywhere between. So I'm going to put 23.5 there. And that is totally correct. Okay. Then remember, always from the celestial equator, I go 90 degrees, not from the sun. All right, and this is what I'm trying to find is the latitude. And so I'm going to say, look, if I add all those together and subtract it from 180, I figure out what my latitude is. And then this one, I get a very special spot. I'm actually at 23.5 degrees north, which is the Tropic of Cancer. Because, remember what I told you earlier, how far does the sun move from winter solstice to summer solstice? How many degrees?
Heidi.
Well, if it goes from 23.5 below to 23.5 above, how far
47.
is that?
47.
47 degrees, right? But look, this one's at an altitude of 43 degrees, right? What's 43?
Mm-hmm.
47.
Hold on.
Heidi.
90 degrees. Yeah, if it's 90 degrees, that means it's straight up. So if I live on the Tropic of Cancer, on the summer solstice, the sun would be directly overhead. But on the winter, it's at a altitude of 43 degrees.
Oh.
So if you was
Follow
on the
steps.
summer
It's all right
solstice,
if you're like, whoa, he's blowing me away. Don't worry about it. I'm just showing you that all this actually works. It all combines together. But just follow the steps that I've done in every single one and it'll work. I promise you.
So, sir, professor, if you was on the summer solstice, where would the celestial equator be? Like right, like at the bottom?
On the summer solstice, the celestial equator, yeah, would be below the sun.
Oh,
Okay. On the winter solstice, the celestial equator is above the sun.
okay.
Yeah, that's
Is there-
the hardest part, is making sure you get the celestial equator in the right place.
Oh, okay. And is there a specific way, like we can see if we got it right? Like, is there?
Like a way to check your answer?
Yeah, to check it.
No, not really. Some problems, yes, like when we were doing the other one, you could check.
Mm,
If you do this kind of problem, let me grab this one here. This kind of problem, where I ask for the altitude of the sun, then you can check, because the altitude of the summer solstice and the winter solstice, if I subtract those two, it has to be 47.
right.
Okay. But if you're finding your latitude, there's no way to check to know for sure. The key is, especially when you do the homework and when you do the test, especially, is draw all these pictures. Even if you make a small mistake, I'll give you most of the points for the problem. But if you put down and you have the wrong answer and there's no picture, you're going to get no points. So I want to see the picture, because that shows me that you have an understanding of what's going on.
Okay.
Other questions?
No?
No.
All right. Is the class going okay so far?
Yeah.
Yeah,
Yes,
for
sir.
sure.
No problem. Are you
Yeah.
learning
Yeah.
stuff?
Yes.
Okay, that's good.
Yeah.
It's been pretty cool so far.
Okay, well, good. Yeah, it's got a lot of great stuff in this class. It's not going to be easy, but you'll be able to do it and you'll learn it, and you'll come away going, wow, I learned a lot of stuff. So that's what the point of the class is. Anything else
Sure.
I can do for you right now?
When's our first test?
The first test is on September 24th, which is like
Okay.
3 weeks away. And it'll cover up through eclipses if you're looking at the content. So we're currently on seasons. There's like 3 more modules. So we go through about a little bit more than a module per week. Remember, tomorrow there's another quiz for you to take. It'll be over the seasons module.
You gonna do like the highest grade, and you gonna drop the other one again, or no?
I always drop the lowest homework, or the D2L automatically drops your lowest homework. So it's going to take
Okay.
all the homeworks from the whole semester and it's just going to drop the lowest one.
Perfect.
Thank you.
Okay. Well, if there's no other questions, I guess we'll end this session. Any other questions?
I don't have any.
Okay. Well, thank you for coming. I hope this helps. And I can do this at other times too, if you just let me know. If you're needing help, if several students need help, I'll just do the same thing. Switch back. Thanks for coming, and good luck with everything. Email me if you have any problems.